Hi, and welcome to Chapter 15. This is the last chapter we're going to cover in this book. There is one more chapter, Chapter 16 on database administration, but we just don't have time to finish it in this semester. So Chapter 15 is all about connecting your database to your application. So whether you're writing your application in C#, in Java, in JavaScript, whether you're doing a web-based or a Windows app, this is going to talk to you about how to get your database into your application. Let's get started. The first thing we talk about is database connectivity. What is database connectivity? It's simply connecting your database to whatever you need, the client. So DB connectivity is generally considered a middleware. It is the piece of software that connects from your front end, user interface, end user section, website, to the back end, which would be your database. So how do you get from your database to your client and vice versa? How do you get information back and forth? This little piece of middleware that we call your database connection or connectivity is the part that does that. So if you want to connect to your database, there's a couple of different ways to do it. The first is what we call native SQL connectivity. That is the software that is provided by your database vendor. So that's your SQL Server Management Studio or Oracle's SQL StarNet. These are different pieces of software created by the vendor of your database to connect to the database. These do not connect data directly into your application, although they can have some APIs and some ways of doing so. The other ways that we use are either Microsoft's Universal Data Access, which is your ODBC, your OLE-DB, or your ADO.NET. Those three are all three Microsoft products, or Oracle's Java Database Connectivity. So JDBC is the Java version of Open Database Connectivity, which is Microsoft's version. We're going to go through each one of these and explain them, so I'm not going to go into what the acronyms are at this point. We'll do them in the next slide. Recognizing that this database connection is the middle connector between your application or your end user and the data source itself. So again, the first one, the native SQL connectivity. This is the one that's provided by your vendor. So depending on who you are using as your DBMS will determine which one you're going to connect to. Over on the left-hand side, we have Oracle's native connectivity, which is their program called Oracle StarNet. And then on the right-hand side is your SQL Management Studio. Each of these are proprietary. They belong to the vendor that created it. And most of the time, I don't think Oracle has updated their native in probably 20 years. Most of the time because you already have ODBC and you have JDBC, and why would I need to update this? There are ways to connect to the database through those. Also, depending on some of the other ways that we're going to talk about being able to get into your database, you don't really need to create your own native way to connect. But it is possible, kind of like with SQL Server, how we're using Studio, to do that, to be able to visualize our database in just one single application. So let's start with the basics. ODBC, Open Database Connectivity. ODBC started in the 1990s when web-based database connected websites started to become a thing. You wanted to be able to have your database, and you wanted to be able to have the database doing its database stuff, but you wanted to create an application that was going to connect to that. And you were like, how am I going to get the data from my database to my application so that I can run code on it, check some stuff, go through my record set, display it for the user, add stuff, insert queries, so on and so forth. Knowing all of this information about databases doesn't do you any good if you can't get to it with your application. So when we created ODBC in the 1990s, it became the most widely supported database connectivity. It was an open source type thing from Microsoft. You used ODBC and everybody used it. It allowed any Windows application to connect to a data source using SQL. And it used what we called an API, Application Programming Interface. And you may have heard that before in your other programming classes. An API is a way to interact with programs between applications. So it's an Application Programming Interface, an API, and you were able to add to or connect to your database and then run queries against it. The screen I have over here is your basic ODBC data source connection. So to connect to my data source, I needed to know what type of driver I'm going to do. Is it an Oracle database or a SQL Server database or a DB2 database? I needed to know where the server was, and I needed to know the other parameters like my username and password. You could enter all of these in to create what we call a data string or a connection string, which would allow you to connect to the database with that data string. Once ODBC started, they realized that, yeah, that was great, you can get the data across, but we weren't able to do an object-oriented information with it. So with ODBC, we added in the concept of data access objects, or DAOs. And this was an object-oriented API that was used to access your desktop database. Now, you have to remember, back in the 1990s, things were different. If you had a Microsoft Access database sitting on your computer, you wanted to be able to access that to be able to do things with your application. So I want to be able to create a front-end access thing, and I want to use Microsoft Access on the back. DAO allowed us to connect to a local database on the local machine I'm working on and add that to a Windows application, which was kind of cool at the time. Then we came up with a remote data object, or RDO, and an RDO was an object-oriented API that was used to access your remote databases. So this was not your local access on your local machine. This was your SQL Server, your Oracle sitting over in a server somewhere. So your remote data access allowed us to connect remotely through ODBC to get that information back across. When this is done in Windows, we use dynamically linked libraries, or DLLs, to do the connections. Your computer right now already has all of these DLLs installed. So they're already set up so that you can do your ODBC, or if you have installed Visual Studio, or if you've installed any type of programming software, those DLLs are already included. So you should be able to just immediately connect with your application and get the database connection across, to be able to run queries against it, connect with a connection string, insert queries, execute queries, select queries, so on and so forth. So this is your basic open database connectivity that you're going to be using. ODBC worked great, except that it did not do anything for non-relational databases. So there was no support for flat files. There was no support for any other type of database, like a object database, a document database, a graph database, any of these other non-relational database options. So they created OLE-DB, Object Linking and Embedding for database. And OLE-DB created the ability to be able to query against non-relational databases. It can query against relational databases as well. But it was the point of it was to get into the non-relational databases, to be able to use components, either having your consumer be the application and the provider managing the connection. This did not support any web development. So OLE-DB has kind of gotten obsolete lately. OLE-DB created the concept of an ActiveX data object, which was Microsoft's version of an object that was created through this OLE-DB and the application. Instead of it being a record set, instead of it being a set of fields and a row, this was a section of objects. These were called ActiveX objects. Okay, your ADO.NET is the final result Microsoft came up with between ODBC, then you got to OLE-DB, and then they created ADO.NET, and that was the current access that is used with all .NET applications. This is kind of taking OLE-DB and ADO and making it as good as it can. You can provide data sets, there's XML support, and you can do a disconnected data source. So once you have connected to your data source, gotten the records, you can disconnect and still keep using those record sets. They understand things like constraints and keys and how those work. So the list over here on the side are different objects that are associated in your ADO.NET libraries, the things that you can use with ADO.NET to be able to connect to your database. First and foremost is your connection. You will always create a connection first, and this uses your connection string to actually create a pipe connection between your database and you. Then I can do things with that connection. Second level down is your command. This is your SQL statements. Your commands can execute a query to return a record set or execute a query that just does something like an insert query or an update query. It doesn't return anything, but it does execute the query. So we can return a record set from a query or just execute the query with our commands. So we tell it what the query is, what parameters we want to use in that query, and then go forward from there. Then we have a concept of a data reader. So a data reader is a serialized, it goes straight down, read only, forward only data reader that will take the resulting record set from our command and be able to iterate over it and get the data out. But it only goes one direction. You run through the whole thing. You're inserting it into an array, you're inserting it into some sort of a list, something like that, but you're just going to run through it one time. Then we create a data adapter. Now, a data adapter is really kind of a cool concept because it's designed to manage your data in your data set, doing selects, inserts, updates, and deletes, understanding what the record set is, and being able to adapt as it goes along. With our data adapter, again, we have that data set, which is the whole set of data that is inside of our table or our return query from our SQL statement. This is the in-memory representation of the data from that command. So if I did select star from customers, this is the customer table that comes back. It holds both a data table and a data relation collection. The data table is the actual table, and the relation collection holds the relationships between it and other tables. The data table itself contains the primary key, knows what the primary key is. It also knows what the column definitions are and the constraints. So this is a whole lot more than just storing a table as a series of records or a series of fields. This is starting to take into account items from relational databases to be able to connect and use that data inside of our application. There are some applications that you can do, especially web-based applications, that can use this ADO.NET to be able to connect to your record set, be able to allow you easily to insert records, delete records, change records on the fly in your website by using this data adapter and the data set inside of it. So lots of powerful things that you can do with this one. The last database connectivity we're going to talk about is Java's, because Microsoft cannot own everything. So Oracle, which bought Sun Microsystems in about 2010, Sun Microsystems built Java back in the 1990s. And they built a Java database connectivity specifically to do what ODBC does, but to do it with Java. Remember, the cool thing about Java is that write once, read everywhere, run everywhere type thing. You can run it on any platform that you want, which allows you to use that same connectivity across platforms as well. So with ODBC, you had to design it for the computer that you were using, whether it was a Windows machine or an Apple or Linux. But with Java, you could do it with all three. So any platform that you wanted to use was fine with a JDBC connection. All right, so those are your basic ways to connect. Now we're going to start to get into why would you use the internet to connect, and then how to do it. Well, I really didn't feel like it was necessary to really give you this slide on why we need the internet to connect, because do we really need to convince you to use the internet? Obviously, there are benefits that come from hardware and software and training time and all that fabulous stuff, but in all honesty, you already are going to do this. So this is the direction everything is going. No one is doing connections across anything except the internet anymore. So we're going to just skip past this slide and move on. The first one we're going to discuss is our server-side extension. So these are server-side. This is the side with the database. So these extensions are the programs designed to handle your request from and to the database. So from the server to the server. So the web to the database middleware. Remember, this is a middleware that goes from your client to your database. In this section, it's kind of that beige color section. This is all of your middleware that handles your web server. So your client's hanging out over on their client side. They're going to make a request to your website. They're going to go through the TCP/IP network, and they're going to get over to your web server. This is where the middleware starts. The web server is going to take that scripting page, and it's going to go down to your server-side extensions. Those are going to discuss through ODBC, ADO.NET, JDBC, whichever one, your database, to get the information that you've requested. Then they're going to take that information back from the database and turn it into a web page. So they are going to convert it down, whatever it needs to be, to do the server-side scripting to create that web page. Now, these can be written in languages like C#, C++, F#, Java, any of these types of languages. These are not scripting languages at this point. These are regular programming languages. They're going to create that website and they're going to hand it back to the web server, which is going to send it back to the client. So all of that middleware is all your server-side connections, extensions that are going to connect to your database and send it back to the client. This is how we create our dynamic websites. So we call them database-driven dynamic websites, something along those lines, which simply mean that everything in the website is created from your database. Your database is going to be giving you all the information and handling that. The nice thing with this is that if you do it well, it is pretty transparent between the website and the database. You simply go to the website and there's all the data, and you click things, data gets updated, and it's all just lovely and beautiful. To connect to the database, we use what we call a web server interface. Either a CGI, I have the acronym backward, a CGI, which is a common gateway interface, which goes through an external program that you're going to build and then goes down to ODBC or ADO.NET to the database. Or you can use what we call an API, which is an application programming interface to create a series of webhooks that connect to the database and allow the web server to just grab information directly without going through an external program. Depending on how you have built your backend server-side extensions will determine whether you're going to use the CGI or whether you're going to use the API to connect to the database. You can go through both. You can write a CGI gateway interface program that will go through that direction if that's the one that you choose to go with. APIs are sometimes easier. And there are APIs that are already pre-built for a lot of things that you can use. So we're going to show you a little bit of examples in the next slide, about how to connect and what that code will actually look like. The other half of server-side extensions is your client-side extensions. These are your plugins. These are your JavaScripts. These are your VB scripts, your ActiveX controls. These are the things that run on the client's computer. These can sometimes be those obnoxious pop-ups that you just love on your web browsers, but they can also be your JavaScripting languages that you use to build your interactive sites. With most of your database-driven websites, you're going to have both a client-side and a server-side side to this. So the client side is going to be your JavaScript. It's going to be the stuff that interacts directly. You might end up using React or Blazor or Angular or one of these other keywords that we use to describe how to connect things and build the website on the fly from data. These are the client side of this. These are your scripting languages. Microsoft has Visual Basic Script, VB Script, as opposed to JavaScript, although most things honestly use JavaScript. And then, of course, you have ActiveX, which is the kind of alternative to Java, but it was designed to be used in Internet Explorer. Anyone remember there was a browser, it used to exist. So a lot of ActiveX controls don't work anymore. We also have what we call web application servers. So if you go into your Visual Studio.NET, over on the side or over on the top, depending on where you have it on your dashboard, there's an option for servers. You can connect to the server and it'll connect directly to your database and show you all the things that you can see in like Studio on your Visual Studio. That might sound confusing. SQL Server Studio, Management Studio. So you see all those options. These are all my tables. These are all my record sets, and I can run queries against it. In Visual Studio, you can go to the Server tab and be able to connect to the server from there and see all of those things as well. So these application servers that come in your development environment can allow you to visualize that connection as well. We use these a lot when you're writing your database-driven websites because I need that quick connection to my database. So in Visual Studio.NET, which is Microsoft's, Cold Fusion has one, WebLogic on Oracle, and then WebObjects on Apple. All four of them have this option of being able to view your server, your database server, your web in your web application software. So that's kind of convenient. Okay, so I did promise you that you would be able to see connections to databases from actual code. One of these is from the book, and one of them is actually from one of the projects that I'm working on. I don't think there's anything too proprietary on that one, so I'm not too worried. So this is a connection to the database in your web development. Obviously, this is not a web development class, so I'm not going to really get into this, but I do want you to see how these are connected. So with the one on the top, we connect to an access database on the user's machine. You can see that it has a connection object, and it has a string, which is my database path, which they have created. This is using, I think it's using VB script, I think. It might be using something like that to connect to the database. This is the one that came out of the textbook, I think. So this has a connection string, which just tells you where the database is. It creates, this is a Microsoft Jet OLE-DB for its provider, for what is the connection that it's going to be using for its data source. And then it goes and finds the location of order-db.mdb, because access files end in mdb. Then we open our connection. Once we have opened our connection, we are going to create an object that's a record set, and then we are going to open a select statement into that record set, and then we're going to be able to go play around with that. So this is connecting to a local access database. The second one is actually written in a language called F#, which I've mentioned a few times, so it might look a little weird. This does exactly the same kind of thing. First thing we do is we open a new SQL connection. And this is written in Visual Studio. So in Visual Studio, in F#, there is a SQL connection as opposed to an ODBC connection, which just connects directly to SQL Server. So when you're using SQL Server, it's pre-optimized for that. So we do a connection to a SQL Server, we open the connection, we create a command, we give the command our select statement as our strings, we tell it what our text is and what our parameters are. In this case, we've added a parameter of an account ID. And then we use our reader to execute and read that. The try and finally with the match is being able to read it and make sure that there are records, and then whenever you find a record, go ahead and do it. That's a story for an F# class, which we're not getting into. But the point of the matter is that both of these pieces of code do essentially the same thing. Connect to the database, create a command, execute a query, and walk through the query. Run through it into a reader or an array or something along those lines. This is actually what you're going to do to connect for your database. So you don't have to worry too much about, is it an OLE-DB? Is it an ADO.NET? Is it created correctly with all of these different little things? Yes, it's middleware. This is the code for that middleware. So it's not a huge amount of code to connect. You might add in more functionality. I want to get this query versus that query. I want to make sure that I can update this field versus that field. But you can see that it's not that complicated to do that connection. The next section is on XML, and most of you have probably seen XML at some point in your career up to this point. But XML is short for Extensible Markup Language, which is similar to Hypertext Markup Language. They're actually both derived from the same standard generalized markup language, which is just a way of using tags to differentiate how you want something to be displayed. So when you do an HTML, you can do a header tag and you can do a bold tag. With XML, you can differentiate the different object types. So in the XML that we have at the top from the book is a product list. Inside of that is individual products, and inside of that is individual fields in the products. So the code at the bottom is customers with all of their attributes, then invoices with all of their attributes, but again, still in that XML format. One of the kind of nice things about XML is that the meta language used to represent the data objects are used as tags, but they're kind of readable, but they're really readable by code. So it's really easy to take an XML document and convert it into a direct array of objects, and it works lovely. By the way, just for kicks and grins, I threw in there the SQL Server run as XML. Yes, you can run your query as XML, and instead of it turning it into a regular record set that you can view as a grid, you can actually turn it into an XML document. So this is the document that I created from this query using SQL Server. So you can go into SQL Server and you simply add at the end of your query for XML. Now the auto part determines how much information do we put in as far as what are the object and schema names. Auto does it automatically and tries to make it as nice as possible. In this case, I have named my customer table customer and my invoice table invoice. If I had named them C and I, which I tend to do when I'm being lazy, the object itself in XML will also be C and I. So you have to be careful about how you name those. But this is using the for XML auto command in SQL Server to be able to take a SQL Server query and turn it directly into XML. Once it's into XML, now you can convert it easily into Excel or any other comma delimited file, so on and so forth. I'm not going to spend too much time on XML presentation and XML apps, even though they are kind of interesting. Most of the database-driven websites I do not go this direction, but it is a direction I want you to know that exists. So XML presentation allows us to take XML documents using a schema and using a transform language and turn it directly into HTML or Excel or text field or so on and so forth. They even have the concept of XSL style sheets, which are similar to cascading style sheets from your HTML class, which allow you to format that transformation. So being able to take those objects and transform them into an easily understood format is kind of a nice concept to be able to do that. There are applications that you can build that do this directly. So rather than turning it into HTML or turning it into something more visual for the user there, you might want to use XML applications to do some of these things. The business-to-business exchanges is kind of a big one, because if you can build your system in such a way and your vendor or your customers have their system business-to-business, we don't care as much about the interface to look at. We just want to get the data from point A to point B. So being able to convert it into XML and be able to ship data across is kind of useful. So long section in the book on this one, but I'm just kind of going to gloss over it with this and let you move on. The last part of this talks about the concept of cloud computing, and we've covered cloud computing a few different times. So I'm just going to kind of gloss over this one as well. Cloud computing is simply the idea that we can store information, servers, virtual machines up in the cloud so that they can be accessed from any location. They do not have to hold a specific place. There are three different ways that you can implement your cloud computing. First, you can have a public cloud, which is your Azure or your Google or your Amazon Web Services. These are public clouds that are available to anybody. That being said, as a company, you can create your own private cloud where you create a cloud services that are only available by your organization. So instead of it being available to anybody who wants to pay for it, it's only something for you. You control it. I'm wary of this for small companies just because I believe that either Microsoft, Amazon, or Google are probably a little better at making sure that I'm protected from hackers than I am, because that's not my thing. So if you don't have the technological expertise to ensure all of those security safeties, the backups, the redundancies, it might be more useful to use one of the public clouds. There is also the concept of a community cloud, which is a specific group of organizations. Generally, they have their own IT staff or it's outsourced. But essentially, this is something where a group of organizations get together and say, we want to have our own cloud that is not a Microsoft, Amazon, Google version. Of course, those three own everything. So, you kind of wonder about that. So this is your community clouds. Now, a cloud infrastructure, a cloud implementation kind of has a lot of different things that are associated with it. First is that it's all accessed via the internet. You have to use the internet. If you don't have internet, you can't get to it. So when we think of it as the cloud, it's something that you have to have that connection to the internet to get to. It's generally on a shared infrastructure so that it can be easily shared amongst multiple programs. Usually it has a low startup cost with this variable pricing. So you can go get a database from Azure for free in some cases. You can go build a free website on Azure as long as you don't mind having Azure free websites as your URL. But there's a lot of things that are really low cost with cloud computing. Obviously, it's flexible. You can go really low cost, you can go really high cost, you can scale it any direction you want. It's dynamically provisioned, which means that as you change the requirements on their portal, those change automatically. Everything is dynamic. Nothing is hard-coded in this. Everything can be changed. Cloud computing is generally service-oriented. It's designed for services, so the different ways that things can be used in a service. And of course, they do their managed operations. So if you have your operations that need to be managed by a cloud computing option, that's always an option with your cloud computing. So managed operations, meaning that your company's operations need to all be controlled, but they need to be used in multiple locations so we can put them up on the cloud. So there's different types of cloud services that we've talked about. So there's the general internet, and then there are different services that are provided when we talk about clouds being service oriented. These are the different types of services that we're talking about. And we always like our acronyms. So we have our SaaS, which is our software as a service. We have our platform as a service, and we have our infrastructure as a service. So first off, our software. This is your Microsoft Office Live, your 365, your Google Docs, Salesforce, SAP, things like this. These are the services that you provide. And the nice thing about these is they used to be software that you would purchase and install on your machine, like your Office 365. Now you can have that installed in the cloud and be able to use it directly from there. Microsoft Exchange, you used to have to have an Exchange server that handled all of your email. Well, now it can be done on the cloud as a service for a monthly fee. All about a monthly fee. Our platforms as a service. So our Azure platform, our Microsoft SQL Server, our Google applications, things like this, our databases. This is more of a platform rather than just a single piece of software. And it can also be provided as a service. By making it as a service, it means it's a monthly fee, but they manage making sure it stays up to date and that it stays safe and it stays available to you with that fault tolerance we've always talked about. The last one, of course, is our infrastructure as a service. This is your MapReduce or your cloud computing, load balancing, actually doing all of the infrastructure that you need to make things work. We can do those with a service as well. All of this is done in the cloud. By doing it in the cloud, you don't have to worry about having any of the hardware in your location. You don't have to worry about keeping it safe. And you don't have to worry about things like data security and data redundancy because the cloud can handle all of that for you. There are some disadvantages of using the cloud. The cloud is not perfect. God knows, nothing is. But there are some advantages as well. So in the book, we describe the differences between the advantages and the disadvantages. The advantage being that it's available from anywhere. The disadvantage being if you don't have internet connection, it's not available at all. So security and privacy. Yes, they're usually better about making sure that they follow basic securities, but the security and privacy, you're letting another company to handle all of that for you. You're trusting Microsoft and Azure and Google to handle it. So is that a good thing or a bad thing? Definitely the cost issue. It's cheaper to get started, but then is it going to be harder for you to keep it up to date? And that monthly fee, is that going to kill you over time when you could have just bought it once and used it for the next 10 years? Lots of different issues that go back and forth between the advantages and disadvantages of cloud computing. A lot of companies really get sucked into that I don't have to put a huge outlay of information to begin with, which is huge, especially depending on the level of your company. But maybe that's a bad thing. So you need to be aware as the database administrator, as the person kind of offering this to your clients, do you want to go with the cloud computing option, or do you want to spend the extra money for the infrastructure now? Do you want to maintain it? Do you want to keep control of it all at the same time? Our last part about this goes back to the cloud computing of giving you SQL data services, which is simply hosting your database on the cloud. We had to get there eventually. We've kind of been talking about it this entire semester. So having your database hosted on the cloud, it's really great because you can get it up and running in literally minutes. You watched me push them up the other day. You don't have to worry about your backups, your faults, your scalability. You've got your fault tolerance, you've got your reliability, and it works fine. So the option of being able to have your database in the cloud adds this whole new level of freedom that you have of different ways of programming. Not to say that it's always the best. As we said in the previous slide, there's always disadvantages. But there's also a lot of advantages, especially for people that think that they're not technologically savvy enough to handle having a database on site. Being able to have it on the cloud means that you can use it without having to worry too terribly much. So that is the database connectivity connections chapter. Big things to remember, that your connectivity is kind of your middleware between your database and your end user. We use our ODBC, OLE-DB, ADO.NET. They're all Microsoft's things. You can have database access through your middleware, so your client-side and server-side extensions. We talked a little bit about XML, gave some information about cloud computing, and then, of course, our SQL data services. I hope that this has been interesting for you, and definitely understanding how the data is connected to your end website and how you get there. So I went through the questions at the back of this chapter, and I didn't think any of them were necessary. I think that we've covered a lot of these things, and there's no reason for you to be redundant about writing the same answers again. So I have 3 things that I want you to do, and none of them are in the book. So the first is I want you to connect to SQL Server through Excel. This is a nice, quick, easy way. Everybody has Excel because Great Falls College pays for that for you to have a version of Excel on your computer. If you've not already done it, go into Microsoft Office, ask me how if you don't know how, to get a version of Excel downloaded on your machine. Once you have Excel, you can go to data and then get data and get it from Azure, and you can enter in the connection string to get to your database. You should be able to figure out how to do that. I want you to go connect to your database. I want you to go get one of your tables. I don't even care which one. I just want to see you do it. I want you to bring it out into Excel. So it's going to be sitting on your Excel screen as a list of data tables. They are not 2-directional. So if you change the Excel data, it does not change it in the database. So then you have to go back over to SQL Management Studio, and I want you to change the record of something. Change someone's phone number, change someone's last name. I don't even care. Just change something. Then go back to Excel and hit the refresh button and show me that it changed. This is one of those funny things. And then the last part of that is I want you to go make some sort of charter graph, something, I don't even care what, from your data to show me that you can take that, visualize that. So if you want to use some invoicing from one of the companies that we've done, this is a great way to just kind of practice getting stuff into Excel and being able to use the visualization. Give me screenshots before you make the change, after you make the change, and then make sure you do the screenshot of the chart. You do not have to include the Excel file, although you can, because I don't actually want any connection to your database in any files, but you can if you want to. I just don't want your password. That's kind of a big thing. So you should be able to connect with your just Windows login, and that should allow you to get into that. So that's number 1. That's the first thing I want you to do. The second is I want you to use the SQL query as XML in your SQL Server to include 2 tables of data and then write them as XML. I want to see you get an XML from one of your queries. The reason I want you to use at least 2 tables is because it will do that multi-level thing that XML does. If you only do 1 table, select star from customers, it just gives you an XML list of customers. But I want the interior data, so I want the second level down. So I want to see at least 2 tables worth of data stored as XML. Again, give me the XML file. A screenshot works fine. So that works for number 2. And the last one is going to be a little bit more difficult. I know you're in the middle of working on your final and you really don't want to spend too much time on this one. So I want to know how you would connect to a database if you were building a dynamic website. You can pick your server-side language. If you want to do C#, F#, PHP, Java, I don't care. Pick your server-side language. Go online if you need to figure out what the connection string is, how it would work. How would you connect to your database using one of these languages? And go type it up. So if you want to go into Visual Studio to type it up to see if you can connect to the database there, that would be fabulous. If you have a different environment that you want to write software in, that's good too. This is not something I'm going to test to see if the code works. I want to see what you can come up with. I want to see what language you pick, and I want to see that you've thought about the connection string, that you've gotten a connection, you've done a command, you've gotten the record set, and then how you choose to display the record set. So you are going to submit to me how to connect to the database. Make sure you don't include your password. Star it out. I don't even care. Just don't include your password because I don't want to know it. Create a command. Run a simple select query. I don't care if it's select star from customers, select star from invoice. Do a SQL command, something, and execute the query and loop through the record set. So just show me what the code would look like. It might take you 10-15 minutes of searching on the internet to find it, but I want to see you do it, so that if at some point after this class you have to go make an app and you have to connect to your database, you already have a way in your head of how to do that. Include any screenshots that you've done as you go along, and any comments. This is kind of the fun part. I want you to tell me how it went. Summarization. Did it work? Was it easy? Was it 4 lines of code or was it 14? Which language did you pick? Which environment did you pick? so on and so forth. So these are kind of open-ended, but I want you to actually try to learn something that you can kind of take with you when the class is over. I really, really hope you have enjoyed this class, at least enjoying something about databases. Like I said, this is my bread and butter. This is my life. I love database-driven websites. And everything I do is generally go to the cloud, get the database, put it out on a website. So I hope you have a fabulous week. Please make sure you talk to me, ask me questions if you have any of them, and I hope to see you soon.